Hello, let's continue our Sudoku adventure with additive groups by GDC. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. All right, now all digits on the same line have the same even-odd parity. Parity is just the property of being even-odd. So once we place a single even on the line, the rest of the line must also be even. So something like that would work. If we place an odd on the line, then the whole line is odd. So every single digit on the line is either all even or all odd. Simple as that. Also, all the lines in the grid have the same sum. So if this was, again, 2, 4, 2, 6, this would sum to 14. That means all of these lines sum to 14. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. How do we want to get started is, of course, always the question. Okay, so since all lines have the same parity, I don't know whether this is all even or all odd, but I do know it's all green. Whatever green is, we're going to call it that. Now, you'll notice that the rest of this row, okay, well, let's put it this way. There's 3 evens and 3 odds, 2, 4, 6, 1, 3, 5. So they're used up in this row. We're going to have 3 greens and 3 purples in each row, purple being whatever green isn't. And so that means now that we have a purple on this line and on this line, these are all purple. That means the rest of this box is green. The rest of this column is purple. Rest of this row is green. Oops, green, I clicked wrong. Rest of this box is green. Rest of this column is green. What else do we got? Oh, this line got a green on it, so those are green. We don't know if two is green or purple yet, but that's probably going to tell us something important. Rest of this column's purple. Is there any more to do? So I usually miss something, but this might be enough to go on. Really, it would be really nice to color the 2, but suspiciously we cannot, as far as I can tell. All right. Of note, if 2 is green, then the rest of the box would be purple. But I mean, I guess that's true wherever we put the green. Okay, so we got to think about these lines then. They all have the same sum. This line has all 3 even or odds, and this line has all 3 even odds, but the other ones. So let's just think about how, just arbitrarily, I'm picking this to have 2, 4, 6, and this to have 1, 3, 5. But it could be the other way around. But we're just writing this out so we can think about the logic here. So the sum here is going to be 12, and the sum here is going to be 9. Meaning the difference between these two has to make up that difference. This has to be small and this has to be large. So if this is 12 and this is 9, the difference is 3. So these are exactly 3 apart. So this one has to be from 1, 2, 3, and this one has to be from 4, 5, 6. But we know that this is all odd, so it has to be the 5, and this is all even, so it has to be the 2. So that does work out. And if we just double check our math here, this adds to 14. 12 plus 2 is 14. And this adds to 9 plus 5, which is 14. So this is a 2-5 pair, is kind of our conclusion here. Now, what else can we say about that? So that means we do add to 14. We know our sum. So these add to 14, and they're all even. Or sorry, we don't know they're all even. They're all purple. They're all the same parity. How about three of the same parity adding to 14? Well, if you think about that, 14 is an even number. So if you want 3 numbers that are all share the same parity to add to an even number, they better all be even, because 3 odds add to an odd number. So these are even, meaning this is our 2, this is our 5. 2 is green. And what I'm going to do, since I'm so used to it, I'm going to change all our greens to blue and all our purples to orange, because now I concretely know what's what. So that makes these orange. Finish the row with orange. Finish the box with blue, or the column. An orange and a blue here. I don't think we can resolve these yet. Okay, so 3 evens that add to 14. The biggest we could do is 6, 6, 4, which is just over. This would have to be 6. This would be a 4, 6 pair, and that would add to 16, not 14. Oh, yeah, I guess I can put 4, 6 here. If it's blue, I don't need to put 2, 4, 6 on it, because blue already means that. But the 5 actually goes here for the column. So then this is 1, 3. All right. Anyway, we got to add to 14. So what I was saying is 664 adds to, we need to lose 2 from that. But the problem is this is so easy. This is a 4-6 pair because the 2's in the box. That adds to 10. So to get to 14, this has to be a 4. I was about to make that conclusion anyway, that the only place we have 2 degrees of freedom is here. But I took the long way around for that one. That's a 6. This is a 2-4 pair. Nothing wrong with taking the wrong way around, or the long way around. All right, the scenic route. So these are a bunch of odds that add to 14. Notice there are 4 of them, so that works. Biggest this can be is 3 plus 5 plus 3, which is 5 plus 6, which is 11. So this has to be 3 or 5. It can't be the 1 because we won't get big enough. 3 plus 5 plus 3. Yeah, just double checking. This is 4, 6. Oh, sorry, this isn't 2 or 4, so this has to be 6. That's quite nice. This is 2 or 4. Oh, again, it's not 4, so that's 2. That's 4 and 2. All right. That's 6 and 4. I don't think getting evens is going to help us with the odd digits on here, though. Once you separate the whole grid into evens and odds, it's like 2 different Sudokus. They don't affect each other unless there's a constraint that spans them. But in this case, there's not. This has to be 4 for the row, and this 6 makes that 2 and 6. This is a 2. This is a 4. We're basically finishing the evens. Okay. So 6 in this box goes here, so we can finish our evens. That's odd. That's even. This is 4. All right. Evens are all done. So maybe we can do more with odds. This is a 1-3 pair. This is a 1-3 pair. This is 1-3. This is odd. So the 5's up here. Is there anything else we can do here? I'm wondering if we can sub-color the odds to figure out what this needs to be. Maybe I'll think about this harder. Okay, can this be a 1? Is the first question I want to ask. So if this is 1, then these need to add to 13. Biggest we've got is 5 plus 3, which is... Yeah, we have 2 degrees of freedom, don't we? 5 plus 3 is 8, plus another 5 is 13, plus 1 is 14. So, yeah, in general, we have, if you think about the maximum, 3, 5, 3, 3. Sorry, hold on. I didn't think about this pair here. These can't both be 5. That uses up our 2 degrees of freedom. There we go. I can't do 1, 5, 3, 5. It doesn't work. So this 3, 5 pair here, it uses up our 2 degrees of freedom, meaning these are both 3, meaning that's 5 and 3. All right, that's 1 and 3. Again, probably taking the long route. That's 1, that's 5, that's 1. That's our 3, that's 1 and 3. We get our 1 here. That's our 5, that's 1, and that's 5. All right. Well, I liked the logic in this one. That was neat. Also, always appreciate a coloring puzzle. Very well constructed. Thank you, GDC. If you enjoyed this, then why not leave a like, subscribe, and a kind comment below.